No,
Next time we do a check.
because once he starts talking to you, he'll just keep you in for hours.
Bill Chapman, what told you about it.
One time I was downstairs in the Met Lab, I was polishing some samples. He started talking about we were there for about 2.5 hours. I would have been done in 30 minutes. And I would have left. It was like past 5, it was like 6 o'clock. We stayed there till like 8. We stayed there till like 8. He didn't mind, he just kept talking. I almost went to sleep.
How are you today? Dave Peoples. Yeah, I'm undergraduate. Okay. I work with Dr. Bushman. I'll start grad school. My connection. The football helmet. So we do models and football helmet. Also run the student design team for the Society of Engineers. We designed a race car like you could probably call feature that you grew bigger industrial vehicles or commercial vehicles. So there's like a okay. So within a year's time we'll design build a race car. Yeah. Is that going to be a hybrid or electric or just pretty cool car. Competition comes up in Michigan every year. There's 120 teams that come from all over the world that come compete. Yeah, our team specifically has been right about way. We're looking to do a lot better this year. EcoCar does a lot better at competition. Usually our major they have some highlights of those, so we kind of want to join no, definitely. I'm in charge of having operated like the top order of the competition. You don't have any trees in your facility, right? No, Redeemer's moved out. So do you work everybody Orthodox?
Yeah, it's offices there, but then our research.
There's enough battery for this.
Yeah, battery charge now, the media is either full or.
We actually share.
That was in overall injection.
So we need to look at where they need them. Yeah, that was there was a guy came and presented talk talking about when you attach some sort of a fine tuner monitor movement.
Maybe you can bring the plug in and plug in right here.
Basically, for now, this happened before.
I just became a system. Unintentionally. Just to look at it, I guess. Yeah, the reaction.
So it'll be important because, that has a lot to do with the passion.
Okay, here we go.
I'd like to start this afternoon. My name is Denver Seeley. I'm the president of the student organization here at Mississippi State University called the Society for the Advancement of Creation Science. And we host monthly talks on subjects related to science and the Bible. We're trying something new today, which is why we're giving a more explanatory beginning. We're trying a live stream to the internet through YouTube. And this is our trial run. So we think our guest, Dr. John Baumgardner, will be our guinea pig for our local group setting up this live stream. So our guest, Dr. John Baumgardner, has been a scientist at Los Alamos National Laboratory for a full career. and did quite a bit of work in computational physics and simulation of rock dynamics. And he'll get a little bit, maybe explain a little bit more of the background when I turn it over to you. But has, since he has retired, has expanded into a lot more fields of inquiry related to the Bible, accuracy of the Bible, in terms of historical documents, and questions related to the data that's been collected from the scientific community about the history of the Earth. Talk today on cosmology, I'm really looking forward to, and I'll turn it over to Dr. John Baumgardner.
Okay, thank you. Thank you. It's a delight to be back on campus, be with you again. I've been here several times in the last 20 years, and appreciate Mark Horstmeyer, his friendship and his interest in what I do. As Denver just said, my main focus has been in geophysics, in solid earth geophysics, and most of my interest has been connected with a desire to demonstrate that the Genesis flood is a historical reality well supported by observational evidence. Only recently have I gotten involved with cosmology. I've been a good friend of Russ Humphreys for many years, and we've had lots of interaction. I never had gotten really involved with cosmology, but about 6 months ago I was asked to teach on cosmology at a seminary in San Diego, Southern California Seminary. And that motivated me to, or required that I get involved in some of the issues at a deeper level than I had before. And one thing that was exciting that in trying to understand things, that I believe I have some insight, which I'll share today on another major problem for Big Bang Theory. The original talk had to do with the powerful evidence that the Bible provides on the issue of the origin of the Earth. I'm not going to have enough time. Dr. Horstmeyer encouraged me just to focus on the critique of the Big Bang. So that's what we're going to do. If I have time at the end, I may say a little bit about creationist alternatives to Big Bang. But the focus I have today is on the Big Bang itself. Okay, with that brief introduction, I want to say that much of what I share today is taken from an excellent video produced, it came out late last year, actually available only this year, by Spike Sacs, who was in the military space program for many years. And he has a series called What You're Not Being Told About Astronomy. And this is the third video in that series, entitled Our Created Universe. So this one focuses on the issue of cosmology and the Big Bang in particular. All right. Now let me just say that I know most of you are Christians in this particular audience. We are in there's a great battle raging on our planet, and the nature of the warfare is primarily deception, and people are being deceived in all kinds of ways. And in the realm of science, there are, and it has to do with the knowledge of God. And in 2 Corinthians 10, there's a verse about strongholds that have been raised up against the knowledge of God. And I use these castles to represent 5 of the major strongholds that are somewhat related to the scientific enterprise in our day. And most of my life I've been dealing with this castle, and in general this castle also. And I also spent a lot of time working on seeking to tear down this castle. Today we're going to focus on this castle, which basically, to understanding the Bible, the main challenge has to do with the age of the cosmos. Big Bang theology, Big Bang cosmology is a serious assault on the Bible's claim that the cosmos was created very recently. So we're going to deal with that today. In my title, I suggested that the Big Bang Theory is failing. So I raise this question: is Big Bang Theory truly in crisis today? And I'll say yes. Increasing numbers of secular scientists are openly acknowledging the major failings of Big Bang Theory. And this is a quote: Big Bang Theory relies on a growing number of hypothetical entities, things which we have never observed. Dark matter and dark energy are the most prominent. Without them, there would be fatal contradictions between the observations made by astronomers and the predictions of Big Bang Theory. So this writer and New Scientist is being very candid about that without these hypothetical entities that have never been observed, the Big Bang would have there would be fatal contradictions between the observations and the theory. This writer goes on to say, in no other field of physics would this continual recourse to new hypothetical objects simply invoke a miracle and say, we've fixed that problem. Here are three examples of what Big Bang Theory predicts, which are in contradiction to observation. One is the so-called magnetic monopole problem. Big Bang Theory predicts there should be an abundance of magnetic monopoles, and we've yet to find one. The horizon problem has to do with the uniformity of the cosmic background radiation, that it's so uniform, and it's hard to imagine that if there really was a Big Bang, that the temperature across the whole sky in the microwave region could be so uniform. There shouldn't be the ability for the cosmos to communicate and reach equilibrium in that scenario. So it's basically a light travel time problem for the Big Bang. And then there's the flatness problem. It's been realized that for the Big Bang to work, the amount of matter in the universe has to be at a very tightly constrained value, else the expansion will be so fast that that matter becomes so diffuse there's no way for stars and galaxies to form. If there's a little bit too much matter, the universe will collapse back on itself. Propose this, and this is its original paper, Inflationary Universe, a possible solution to the horizon and flatness problems. So this is a moderate commentary on that. A region of space the size of a pea would stretch larger than the observable universe in a time interval so short that the blink of an eye would overestimate it by a factor larger than a million, billion, billion, billion. Basically, basically this theory of inflation says that the universe expanded in it just very shortly after the Big Bang, within the first 10 to the minus 30 seconds. 10 to the 30 to continue to talk about. And in regard to these problems, we know that inflation must be true, because otherwise the Big Bang model would have these fatal problems, fatal difficulties that I mentioned. So inflation is nothing more than an appeal to a miracle by these secular cosmologists. An additional problem alluded to earlier is what's called the missing mass. Galactic rotation, and also to hold together galaxy clusters together. The normal galaxy, the rotation velocity is normally falls off strongly with distance. Like this is what's expected given the amount of mass in a typical galaxy. But as the velocity of these stars as a function of distance from the center has been measured, it's been observed that basically the rotational speed flattens out. And so about the only way people have found to account for this is extra mass somewhere. Actually, the best model is a halo of mass around the galaxy. Extra mass. They've looked at brown dwarfs, stars that don't emit any light to speak of, so that those are on one side. Then because they didn't find any of those, and they've been looked for very carefully, it's because that kind of object would if there's very many of them, would tend to pass across stars, and you could see time dependence of the intensity of light from the stars. And with today's technology, you can monitor literally thousands of stars simultaneously looking for that sort of thing, and it's not been found. So the other idea is weakly interacting massive particles, or WIMPs. The other name was machos for these massive, what they're called, halo objects, massive. But the other idea is, other possibility would be particles, generally thought to be very massive, but also weakly interacting, hardly interacting with matter, so and therefore being hard to detect. And all kinds of experiments have been done on that, and those experiments have largely failed. Have failed. Nobody's come up, not documented any of these weakly interacting massive particles. So dark matter, exactly what is it? What is it made from? Well, the simple answer is we don't know. No known particle fits the description. It's an embarrassment that the dominant forms of matter in the universe are hypothetical. And this quote is from James Peebles, one of the leading cosmologists of our day at Princeton University. So, the leading scientists, the leading cosmologists really admit these, that this is an embarrassment, something they have no answer for. And this is from a web article recently, search for dark matter particles turns up zilch. And so there have been very serious experiments looking for these dark matter particles. This quote, 85% of all the gravity in the universe comes from something about which we know nothing. So that's the status of dark matter. It's again appealing to something to fix some major problems with the Big Bang, and there's no observational evidence that supports it. A further mystery, a study done in the late 1990s of redshifts of distant type 1a supernovas revealed that the expansion rate of the cosmos is increasing. So these type 1a supernovas are sort of what they call a standard candle. They have a very, their brightness seems to be very over just a very narrow range. When one of these explodes, it releases a standard amount of radiation, certain standard brightness. So by looking at just how much light we receive from these things, we have a pretty good handle on how far away they are. So it's a way of determining how distant a galaxy is. If a supernova like this goes off in it, we can look at its brightness and get a good estimate of its distance. Well, this kind of survey did that, and as they looked at supernovas in galaxies from various redshifts, they concluded that the rate of expansion of the cosmos must be increasing rather than decreasing. The Big Bang cosmology predicts that the expansion rate should decrease with time. So this was a big shock. How could the expansion rate of the cosmos possibly be increasing? So what they recalled that Einstein had this lambda term in his equations of general relativity, and he had thought that when he developed his theory, he believed in a steady state universe, and in order to keep the universe stable, he needed a constant. So he added this what was called the cosmological constant, which he later said was the biggest mistake of his career. But anyway, when this fact was discovered, it was realized that reintroducing the cosmological constant, but giving it a very tiny value would explain this phenomenon. Although it also would mean that conservation of energy was being violated. Anyway, so what conceivably could cause the cosmos to expand at an increasing rate? So supposedly, at the Big Bang, if it were really true, the expansion rate should decrease with time. The slope should actually increase here. But what was found is that the cosmos, the expansion rate was increasing. So what the seculars did was they just came up with a label. They just came up with a label. They call this phenomenon dark energy, and to give the impression that they understood it. That it was this was perfectly well understood now. And that this quote here, this quote, to get enough oomph to drive the present acceleration of the universe, dark energy must make up about 68% of the total density of the universe. The biggest problem with this idea is that no one has any idea of what dark energy is. So what exactly is dark energy? The obvious answer is, again, we don't know. Actually, the situation is even worse. We really don't know. And this guy, writing in Science in 2012, the nature of dark energy is now perhaps the most profound mystery in cosmology, and astronomers and astrophysics remain forever so. That's how they're admitting. That's just how
no one would ever know.
Yeah, they really don't have any physics that can give that effect. Okay, so if we evaluate the contents of the universe at this present moment, and this is as of 2015, we have this invisible dark energy that nobody has any idea what it is. Represents 68% of the total energy budget of the universe. 27% is dark matter, material that produces gravitational effects, but is otherwise undetectable. And then only 5% is related to visible matter. Baryonic matter, it's called. Regular matter made out of protons, neutrons, and electrons. So dark matter and dark energy are appeals to unknown entities to solve glaring deficiencies in the Big Bang hypothesis. So what about the Big Bang event itself? What about its causality in particular? So this is an image taken from a NASA website that seeks to represent the Big Bang. And so notice here, they're saying that it originated in a quantum fluctuation. We'll talk quite a bit about that in a moment. And then inflation took over and caused the universe to expand to approximately half its current size in just a tiny fraction of a second, within 10 to the minus 32 seconds. It got that big. With no physics at all behind that idea. And then it took a while for things to cool off enough for even neutral atoms to form. So everything was a plasma, ionized plasma up to that point. Finally, things cooled out enough for protons and electrons to neutralize each other and form atoms, mostly hydrogen and helium, about 75% hydrogen, 25% helium. And at that point, the light, photons could escape, could propagate, weren't immediately absorbed by the plasma. So it's at that point when there was when atoms formed that life could propagate. Presumably, that's where the cosmic background radiation, the source of that. And then somehow you have that's and this is sort of representing the cosmic background radiation. And then after another period of time, there's things cool down enough, and somehow, again, there's no physics, no explanation of how stars could form. By the way, the density of matter at this point in the Big Bang is about 1 hydrogen atom per cubic meter. And to imagine how you're going to get stars and galaxies to form out of gas that is so diffuse, I mean, again, you're having to appeal to a miracle to get a star to form out of gas that's so diffuse. But somehow it's believed that they did form, and that somehow following that galaxies form. And now we can look back apparently in time and actually see galaxies in this time range, at about 500 million years. And they look, by the way, look just like galaxies nearby, look like our own galaxy. No difference in their age, apparent age. And so anyway, and then presumably a development of galaxies, planets, and so on to what we get to where we have today. So this is the Big Bang. This is the Big Bang, basic Big Bang model. So getting back here as to how did this supposed Big Bang occur? Was it caused or not? Well, so there are basically two answers given by the secular community about its causality. The first is that the Big Bang just happened. And one cosmologist on that says it's just one of those things that happen from time to time. So if that in regard to that answer, what it's saying is that the cosmos is a self-existent entity. That it is self-existent, and but in the case of the Big Bang, it's not eternally self-existent. It for some reason just happened in the we can at the time we can go back to looking at the stars and galaxy into the past. But as far as this issue of causality and self-existence, this answer says it's the cosmos that is self-existent. Now, I would say that is an important philosophical issue. Unless you want to give up causality, if you don't want to give up causality, then you're forced to the conclusion that there must be something that is self-existent. There must be a first cause. There must be, Aristotle came to that conclusion. I believe it is a logical conclusion. So, as Christians, what the Bible says that there is a self-existent entity that is God, and when Moses was at the burning bush, and this entity in the burning bush spoke to him and told him he was to go back and tell Pharaoh to let my people go, bring the children of Israel out of slavery, out of Egypt. Moses said, well, what shall I tell them your name is? And God said, tell them that I am sent you. And that even the name Yahweh is related to that verb to be, the Hebrew verb to be, pointing to the fact that God is self-existent. And the Lord Jesus had this this propensity to use that term, I am. Before Abraham was, I am. Unless you believe I am, you shall die in your sins, he said. John 8:26. So we, the Bible is very clear that the three persons of the Trinity are each self-existent persons, and that they alone lie above this line separating what is self-existent and everything else. Everything else is created, and so, but in regard to the Big Bang, people that hold with the Big Bang, they're forced to say that matter somehow is self-existent. Okay, so so you can see this somewhat reflected. So the original Big Bang basically had not only matter and energy suddenly coming into existence, but also space and time. The space, time, matter, and energy it was taken for granted or assumed that the Big Bang represented the beginning of time, the beginning of space itself. So, okay. So in that case, let's just read this quote. The concept of time before the Big Bang is quite possibly nonsense. For most cosmologists, asking what happened prior to the Big Bang is akin to asking what lies north of the North Pole. So this answer says is assuming that time came into existence at the Big Bang. Okay. So that for a long time was the main sense of what people believed about the Big Bang. But there is more recently a second answer, which may to many people sound similar, but it assumes a pre-existing vacuum background. It implies that there was space and time before the Big Bang, and that some of you may not be aware that most physicists now believe that the so-called vacuum, empty space, is really not empty. There's real material there. It's basically invisible to us, but it can be demonstrated that it has properties. It reacts to applied voltage. There's evidence that it's a real material. So this quote is from Stephen Hawking. Because there is a law like gravity, the universe can and will create itself from nothing. Spontaneous creation is the reason there is something rather than nothing. Why the universe exists, why we exist. So this has become a new answer, basically a new answer that it involves us. What it said here, something out of nothing. We want to critique this fairly seriously. Hawking in another place says the laws of gravity and quantum theory allow universes to appear spontaneously from nothing. So I ask, from nothing? No. It can readily be shown that Hawking and other leading cosmologists are making a fundamental error, that word error in their physics analysis. And a leading atheist is Lawrence Krauss, who's at the University of, I guess he's at Arizona State, wrote a book in, I guess it's 2009, A Universe from Nothing, Why There Is Something Rather Than Nothing. So this is now a centerpiece of what we could call the atheist gospel. At the cover of the book, it says "Afterword" by Richard Dawkins. So now the atheists are jumping on this to claim that they now have, that there's no need for God. There's no need to account for what is, because the universe can spontaneously arise from nothing. And I say that is utter foolishness. It can be shown to be contradicted by the physics we know. So how do big bang advocates today seek to evade the inviolable law of conservation of mass energy? Well, I say they have tricked themselves into believing that the total mass energy of the cosmos is zero, or at least small compared to quantum fluctuations of the vacuum, the vacuum background. So let's look at that issue. They do this by convincing themselves that the total gravitational potential energy of the cosmos can cancel or nearly cancel all the other kinds of energy. In other words, rest mass energy equal mc squared energy of ordinary matter, kinetic energy, electromagnetic energy, all these positive forms of energy of the cosmos, they claim can be canceled at the time of the Big Bang by gravitational potential energy, negative gravitational potential energy. So let's just have, some of you may have had physics just review this concept of gravitational potential. Let's just think of a body like the Earth with mass and radius r naught. And for that kind of body, the gravitational potential is given by V, which is equal to V naught minus Gm over R. For R for simplicity, this formula is more complex if you include the Earth itself, but for our purposes, we can just consider R greater than above the surface of the Earth. Here, where V naught is a reference potential, V is the universal gravitational constant, and R is the distance from the center of mass of the body. Okay, so that's the basic definition of gravitational potential, mainly this part right here. But notice I've included this term, this reference potential. And I repeated that equation so you wouldn't have to try to remember it. I'll say V is always defined relative to some reference value, which is an arbitrary choice. And just like electrical potential or voltage, you can use a voltmeter and you can choose what reference you want. If you're going to measure that voltage, you normally connect one of the leads to ground. So you have a potential relative to ground. But you don't have to. I could get the potential relative to my laptop, in case it's not grounded. But in any case, you always need a reference potential. We talk about potential. Same is true for potential energy. The convention that physicists often select bodies like planets and stars is setting this reference to zero. And what that implies that V becomes zero when this R becomes infinite. So if this is zero, V is zero at R equal infinity. Okay, and so that's for many situations that's a convenient choice to make. In that case, if we set V0 equal 0, that means the potential is everywhere a negative number. But we can an equally valid choice is setting V naught equal to Gm over R naught, which in this case would be the surface of the body. So when you put that in there, if you choose V naught, if you choose this, the reference potential to be the reference at say the Earth's surface, if you put that in there, you get this formula, and you can note that V is equal to 0 at the planet's surface. or R equal R naught. You put R equal R naught, these two terms cancel, you get 0. Note that with this choice, B is everywhere a positive quantity. Okay? So it's, and like I say, this choice of B naught in these kind of circumstances is completely arbitrary. You can choose it whatever you want. And the reason it doesn't matter is that in almost every case you can imagine, you're only dealing with differences in the potential. Only dealing with differences. So if you add and subtract an arbitrary quantity, if you add an arbitrary quantity to both measurements, it doesn't matter. You're working with the difference. Okay? So no circumstance, the choice for B naught makes no difference, whatever. All right. Now let's look at what happens in the case of Big Bang theory. All right. Now, I haven't mentioned this, but the Big Bang theory that relies upon what's called a cosmological principle, and that means that the distribution of matter, at least at sufficiently large scales, it's everywhere uniform. And so when that's the case, the gravitational potential energy is defined a bit different, but it actually looks very similar to what the formula we just looked at. In this case, it can be expressed B equal B naught minus A, where A is a constant, over S, and where S is a spatial scale factor for the cosmos. So S is the cosmic spatial scale factor. And S0 is the value of the scale factor at the instant of the Big Bang. So S can't take an arbitrarily small value. It's generally thought that minimum value is what's called a Planck, is called Planck's constant, which is approximately equal to 1 times 10 to the minus 35 meters. So a very tiny length, but nevertheless non-zero, nevertheless a finite length. Okay, so this is the formula that's appropriate in Big Bang cosmology for the gravitational. Okay, so again, let's look. All right, so many physicists used to, in other contexts, choosing this B naught to be 0. It's not surprising that many of them just assume that for the Big Bang. So let's look at what that implies, assuming B naught is 0. That implies that B is 0 when S is infinite. But this involves an ill-defined state for the Big Bang cosmos. It corresponds to a state that cannot be attained, cannot even be attained for many values of the constant density parameter omega, which gives the spatial curvature of the cosmos, including this value of 1, which represents a flat cosmos. We talked about the flatness problem, the fact that the universe seems to be very close to being flat today. Note, however, that this choice leads to an extremely large negative value for the gravitational potential at the instant of the Big Bang. So if you choose B naught equals 0, you get B equal minus this A over a very tiny number. Okay. However, one can alternatively choose B naught equal to A over S naught, so that you get a formula of this kind, which implies B naught equals 0 at the instant of the Big Bang when S is equal to S naught, just like we did for the planet. So in this case, B is positive thereafter as the cosmos expands and kinetic energy is converted into gravitational potential energy. And I claim this is the appropriate choice in a Big Bang context, because the other choice may may or may not be physically meaningful. But this is a meaningful choice. Just repeating myself here, choosing the gravitational potential to be zero at the instant of the Big Bang is the natural choice. Thereafter, the gravitational potential assumes ever larger positive values as the cosmos expands and kinetic energy of the Big Bang is converted into positive gravitational potential energy. There's no reason to assign a value other than zero to the gravitational potential at the instant of the Big Bang. In selecting this reference value for the gravitational potential at the instant of the Big Bang is not only is a possible choice, it is the only reasonable choice. The total gravitational potential energy always a positive quantity. All the forms of energy that contribute to the total energy of the cosmos are therefore positive. Okay? That being the case, there's no way in a Big Bang scenario for the total energy of the cosmos ever to be a small value. And the idea that at the instant of the Big Bang, the total energy was a small quantity with a magnitude comparable to the quantum energy levels of the vacuum, therefore, I claim is scientifically indefensible. It's simply, but it's something that the atheists desperately want. So it's therefore understandable why they might not be so careful about analyzing this. But to me, it's a pretty obvious mistake that they have made. Even Stephen Hawking has made. So here we say, I repeat this quote: the laws of gravity and quantum theory allow a universe to appear spontaneously from nothing. No, they're making a fundamental error in their analysis, and even though they're claiming it and spreading this idea abroad, it cannot be successfully defended. All right, what about this issue of fine tuning? You may have heard of it. Well, it turns out that the Big Bang demands extremely fine tuning. I'm running out of time, I see. Data from the Planck spacecraft indicate that the initial value of the cosmic density parameter omega had to be correct, that is equal to 1, giving perfect flatness, to a precision of 1 part in 10 to the 62nd power at the instant of the Big Bang. Let's consider what that in order for the cosmos not to expand too fast or too slow, not to expand forever or to collapse back on itself. That initial value of omega had to be exceedingly close to 1. So let's and that's controlled by how much mass energy there was and is in the cosmos. This implies that the total mass of the universe must be exact to the precision of a single grain of sand. So if you count how many nucleons there are, baryons that are the universe, you get a number like this. If precision is 10 to, in this case, he was using 10 to the 60th, no better numbers, 10 to the 62nd. That means you have to have the mass energy precise to 1 part in 10 to the 20th. And that corresponds, that many neutrons or protons is equivalent to how many are in a single grain of sand. So that means that in the context of the Big Bang theory, only a single grain of sand added to the total initial mass of the cosmos would have caused it to quickly to have collapsed on itself. An initial mass of only 1 grain of sand less would have caused the cosmos to expand so quickly that no stars or galaxies would have formed. That's just how finely tuned the Big Bang is. another way of putting it, I would say it's a measure of how unlikely the Big Bang is. How this by itself, this line of argument by itself should falsify the Big Bang. And we'll see how the Big Bang theorists, in effect, are acknowledging that the Big Bang is, falsifies itself. And then in the case of dark energy, the situation is even worse, it turns out. I won't explain why, but it requires a fine-tuning to 1 part in 10 to the 123rd power. Okay? So hang in there. Can you wait? Can you give me another 10 minutes? Okay. Some of the fine-tuning appears extreme enough to be quite embarrassing. For example, we need to tune the dark energy to about 123 decimal places to make habitable galaxies. To even have galaxies, not even habitable galaxies, to even have galaxies. Okay? The picture of the universe, this picture of the universe, or multiverse. Now that we're going to have this idea of multiverse in it, as it is called, explains the long-standing mystery of why the constants of nature appear to be fine-tuned for the emergence of life. So what has happened now, in order to deal with this fine-tuning, they are now appealing to this idea of a multiverse. That there's not only one universe like the one we're living in, but as we'll see in a moment, they're appealing to an infinite number of universes like us to account for the fine-tuning. Okay, another quote. This is from an article in Scientific American, The Case for Parallel Universes. The reason that intelligent observers exist only, the reason is that intelligent observers exist only in those rare bubbles in which, by pure chance, the constants of nature happen to be just right for life to evolve. The rest of the multiverse remains barren, but no one is there to complain about it. Another, call it a fluke, a mystery, a miracle, or call it the biggest problem in physics. Short of invoking a benevolent creator, many physicists see only one possible explanation for the fine-tuning. Our universe may be but one or perhaps infinitely many universes in an inconceivably vast multiverse. Most of those universes are barren, but some, like ours, have conditions suitable for life. The idea is controversial. Critics say it doesn't even qualify as a scientific theory because the existence of other universes cannot be proved or disproved. Argue that, like it or not, the multiverse may well be the only viable non-religious explanation for what is often called the fine-tuning problem. Notice that they're being candid about the alternatives. That this is the only alternative they have to a religious explanation for the universe. Fine-tuning. Baffling observation that the laws of the universe seem to be custom tailored to favor the emergence of life. So this is an article entitled "Science is Alternative to an Intelligent Creator, the Multiverse Theory." So they're being very candid about it. But is this idea in the realm of science at all? I would say no, like the previous commentator. So do secular scientists now take the issue of fine-tuning seriously? I say most definitely they do, extremely seriously. So what are some of the implications of the multiverse idea? This is to show how far they are going. This is in the far reaches of an infinite cosmos. There's a galaxy that looks just like the Milky Way, with a solar system that's the spitting image of ours, with a planet that's a dead ringer for Earth, with a house that's indistinguishable from yours, inhabited by someone who looks just like you, who is right now reading this very book, and there's not just one such copy, but an infinite universe. But in an infinite universe, there are infinitely many such instances. If the cosmos is infinitely large, it is home to infinitely many parallel worlds. And I say this is nothing more than philosophical fantasy. It cannot be science because no falsification is even remotely possible. Another quote, if there's only one universe, you might have to have a fine tuner. If you don't want God, you better have a multiverse. This guy's very candid. So the current level of absurdity, there are multiple publications on this topic. It's called the Boltzmann brain. The current level of absurdity in the secular cosmological community is that Boltzmann brains must be the true reality because they are so much more probable than the cosmos we think we observe. So instead of there being a real universe, they say it's infinitely more likely there is simply a brains floating in space that just pop into existence briefly, complete with thoughts, and that's all that I'm experiencing. Everything around me is an illusion. There is no universe, because that's infinitely less likely than just an isolated brain. So that's what's called the Boltzmann brain paradox. A typical observer in the multiverse is a Boltzmann brain. The typical observer, there's good chance there are not any other kinds of observers, or if they are, they're extremely rare. In the eternally inflating vacuum, observers are infinitely more likely to be Boltzmann brains than honest folk like ourselves. Okay? That's the level of absurdity. Of course, they're basing everything on random events, probability. They're calculating probabilities. That's the level of insanity they have reached by rejecting God. Okay. Modern cosmologists have a favorite default theory of the universe called lambda CDM, where lambda stands for the cosmological constant and CDM for cold dark matter. What we're pointing out is that lambda CDM, the current leading candidate for an accurate description of the cosmos, can't be right all by itself. It has a Boltzmann brain problem. It is therefore cognitively unstable and unacceptable as a physical theory, which is, in other words, this means the Big Bang Theory is refuting itself. The fine-tuning requirements are driving them to this point, saying that the probability of the universe is so small that the Boltzmann brain is more probable than the universe. So basically, Big Bang Theory effectively has refuted itself, as those fine-tuning arguments should do. It should prove that Big Bang Theory is false. And here they're finally coming around to that. It's taken them a little longer route. They should have gotten there before, not had to go through this route, but they did. Yet, the entire multiverse concept is predicated on the assumption that the net energy of each universe is zero, or very close to zero, because of negative gravitational potential cancels all the other forms of energy. If that were the case, it makes it conceivable, at least for untold numbers of universes, to come into existence by quantum fluctuation into the fabric of space, as they have convinced themselves is possible. But we've seen that good physics excludes that possibility. The claim that the net energy of our own cosmos is close to zero is scientific nonsense. This means that the multiverse idea is without any rational support. So it just shows the incredible confusion that's out there. And so I would say as Christians, you do not need to be intimidated by Big Bang cosmology. That's the bottom line here. This is the level of absurdity that these people have fallen to, descended to. And so, and the fact that that is the case, you can see here, that they're appealing to a quantum fluctuation based on the assumption that total energy of the cosmos is zero to explain the universe we live in. So individuals promoting these ideas affirm, I say, the sad outcome the Bible in Romans 1 provides for people who do not see fit to acknowledge God any longer. The outcome is that they became futile in their speculations and their foolish heart was darkened. Professing to be wise, they became fools. So this is one of the most amazing examples of that process that the Apostle Paul talks about in Romans 1 that I can think of. So anyway, I've run out of time, but I'm gonna just click this, showing another problem of the Big Bang, namely the cosmological principle is false. And I'm going to, I was going to give a glimpse of some of the cosmological models that are good alternatives, but if I can get there, I'm saying that I review even Tycho's model here in that brief discussion. It now appears among all the major creation cosmologists that there's no significant difference among the models of Humphreys, Lyell, Tinnef, and even Hartnett. They all support a basic model that basically says that God created all the stars and galaxies along the Earth's day 4 light cone, so that all the light from all these distant objects arrive during day 4 on Earth. So all these various models that are current in the creation community all agree on that, and all give an explanation of why the account in Genesis 1 is consistent with the general relativity and the good science that we do today. So I would say stay tuned. It's exciting that there is this kind of agreement right now among creation cosmologists. So I hope you've been able to track with me today. I hope this has been somewhat encouraging to you. And again, I appreciate your interest and encourage you in your faith in the Lord Jesus. Thank you very much.
Thank you, Dr. Baumgardner. I see there was a lot more that you wanted to go through there. But with all that you did go through, do we have any questions?
About your gravitation, can you explain briefly why for omega equals
I would say in that case you could, but there's also the possibility of omega being greater than 1. And in that case you can't. You can never reach that state because the universe collapses back up.
So omega
You can reach that state if omega is less than or equal to 1, but not if it's greater. I think that's right, Pico.
I'm not sure if you asked me. You asked me in the case of the Big Bang technology, right? I think the answer is because they assume that everything is still with matter. And assuming that the assumption that you know is zero, they do that's the case, that the measuring the gravity at a place that's far away.
I was basically, I wasn't claiming that I was making a slightly different argument.
Okay.
I was saying that setting B naught equal to 0, that corresponds to the state of the scale parameter being infinite.
Oh, okay.
In other words, zero density matter everywhere in an infinitely extended cosmos.
Oh, I see. So,
And you can't reach that state if omega is greater than 1. And so the argument is, if for you to have well, I would say in general, your result should be independent. You should get the same result independent of what value you choose for B naught. You can't, for all of them, if you choose B naught, I think I mean,
how do you go about making the gravitation? Because you need that comparison. Whether or not one
ask your question.
how do you measure the gravitational potential of a quantum path? I mean,
In this case, the gravitational potential energy is not, nothing in the quantum vacuum contributes to gravitational potential energy. And presumably the reason is that the quantum vacuum is of uniform density. And so there's nothing that is there to produce. So it's only matter, real matter. At least matter, matter that produces gravity that contributes to gravitational potential energy.
could you use a tracer particle of mass in its behavior in a location within the quantum vacuum in order to make an estimate of
Again,
potential?
if it's just a tiny increment of mass, if there's no other mass, it's not going to respond. There's no traction. Nothing to attract that estimate. We're talking about some issues here in general relativity that most people probably can't understand. But that's the answer.
All right, we had another question.
Yeah, just to clarify, were you saying that the science of fine tuning is kind of the antithesis to multiverse theory? Is it saying that fine tuning is a creationist, like a Christian point of view and argument?
Well, certainly, I personally believe, well, the first person to develop what was called the anthropic principle was a secular person. But Christians picked up on that. And certainly people like Hugh Ross, they have majored on. And I would say that emphasis in the Christian world on the fine-tuning issue probably did push these people to face up to it. But when they faced up to it, they realized it was a major problem. And so the only place they've been able to go, the only answer they've been able to come up with is the multiverse. So that was why I emphasized that, for a long time, I can remember maybe 15 years ago, the secular community just poo-pooed the idea of the anthropic principle. But since around 2000, they've started taking it seriously. And now they take it extremely seriously, so seriously that they're reverting to this writing papers on the Boltzmann brain paradigm.
Sometime back, I think a year and a half ago, a gentleman came through here, spoke over Mississippi State. I think his name was Michael Strauss.
Yeah.
That name ring any bells? He's a physicist from Norman, Oklahoma, who basically took the position that the Big Bang happened, but it was able to happen the way it did because God actually caused it to happen. Are you familiar with that? Any thoughts?
I'm very familiar with that viewpoint. I'm saying the part of it that I didn't have time to go into. The Big Bang requires, depends absolutely on what's known as the cosmological principle. That the cosmos has no center, no edge, and that on large spatial scales, the distribution of matter is uniform. That's known as the cosmological principle. In other words, there are no privileged points in the cosmos. Okay? Well, increasing observational evidence is contradictory to that hypothesis, that assumption. I had in my talk, I've had time, some of the evidences that refutes the cosmological principle refutes the Big Bang.
Yes. So the Big Bang is based on the logical principle and general theory of relativity. The logical principle is the assumption that on a very large scale, the universe doesn't have any structure. Now, that is the simplest possible assumption you can have if you assume that the universe is not designed. On the other hand, if you believe in God, it's logical that you assume the universe is designed. You can point to a single structure that you know that has been designed, but on its largest scale, there's no discernible feature. There's no such thing. So if you do believe in God, the most logical assumption is that the universe does have structure on a very large scale. Now, why am I saying this? Because the assumption of the cosmological principle is the very assumption that there is no creator. And if you start a theory with the assumption that there is no creator, it is logically contradictory to try to marry that theory with the Bible, which starts with the assumption that there is a creator. So there is an inherent conflict in that. Forget about everything else about how the cosmological principle is actually not accurate and how there are all kinds of technical problems with the Big Bang. There's a philosophical problem of using the Big Bang as a means for God to create the universe. Just simply not. It starts with the assumption there is no God, so you can't do that.
Okay. We're thinking about.
So that's a good argument. Another point is that the Bible, if you take Genesis 1 seriously, that the text indicates that the earth is indeed in a special position. And that by itself contradicts the cosmological principle and therefore rules out the Big Bang. If indeed there was, if indeed in the beginning God created the heavens and the earth was without form and void, and darkness covered the face of the deep, and the Spirit of God was moving over the face of the waters. And then on day 2, he said, let there be an expanse or firmament in the midst of the waters to separate the waters that are above the expanse from those that are below the expanse. It was so. You look at that basically and look at what that expanse is described as later in Genesis 1 as the place where the sun, moon, and stars were created. That expanse basically represents interstellar space. And it means basically that the earth is at the center. The center of this large volume in which the sun, moon, and stars were placed. So that Genesis 1 refutes the idea of the cosmological principle. It does say there is a center. Genesis does teach there was a center, is a center. And therefore, if the cosmological principle is false, then the Big Bang, all the Big Bang models are impossible. They collapse. You cannot have a Big Bang model without the cosmological principle. So that's another line of argument, in response to your question. Okay, any further question? I mean, I have all day, but
close the presentation. If you have some more specific questions, we'll talk about that afterwards. I'd like to thank Dr. Baumgardner for coming, and thank you all for attending. Also want to express our gratitude to the Center for Advanced Vehicle Systems that hosted our discussion today. Again, this is the Society.
There's
for
another
Advancement.
presentation tonight, right?
I'm sorry. There's another presentation tonight. It'll be 7 o'clock at Dorman Hall.
And I'll be talking on evidence for Genesis flood. 7.
So bring your water wing.
Thank you.
Dr. Baumgardner?